In this video, we'll walk through some examples of finding the volume of some standard geometric solids. We have a rectangular prism, a cylinder, a sphere, and a cone. For the first two, the top two here, the volume will equal the base area multiplied by the height. And the reason that works is we can consider here with the rectangular prism this base, and we've got this whole area, and then we can stack all of those up. Let's say we stack up all of those areas again and again until we get to the top. So we've got one area plus another all the way to the top, and that's why we can say that the volume is the base area times the height. Because multiplication is just repeated addition. And it's the same thing for the cylinder. You can consider that you have some base area, and then you're stacking that. You're stacking that base area all the way up to the top. Now, we remember this prism or a box formula as volume equals length times width times height, but I've just given you the reason why that works. We're multiplying length times width and then times the height. So let's say we have the dimensions of 5 inches and 7 inches and 4 inches. The volume then would equal 7 times 5 times 4, or that is 140 cubic inches. And our label for volume will be always cubic, inches or feet or meters or whatever units we are using. Now, the base area of a cylinder is pi r squared. So we have our base area, pi r squared, that's circle, multiplied again by the height. So if we have the dimensions for this one, the radius, let's say this radius r equals 2 meters. And let's say we have our height equaling 10 meters. Okay, then we have our radius and our height. Now we can start plugging numbers in. The volume is pi times 2 squared times 10, so that makes the volume 40 pi cubic meters. Now, of course, you could approximate pi as 3.14 and get a decimal approximation of this. I'm going to leave these in terms of pi so we have the exact answers. Next, the sphere. And for the sphere and the cone, we can't just say base area times height. The cone we almost can, and we will get to that in just a minute. But for the sphere, I'm afraid there's just a formula that you will have to memorize. Certainly, there is calculus used to get to that, and that's great and really neat. But for most people, you'll just memorize this formula or look it up and then use it appropriately. So let's say the radius of this sphere is 3 feet. 3 feet. Well, the volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. So we would just plug in that radius. V equals 4/3 pi times 3 to the third power. That equals 27. So we've got 4/3 pi times 27, and 4 times 27 is 100 plus another 8. 108 over 3. 108 over 3 pi. And our label is cubic feet. And of course, again, you could turn that fraction into a decimal and then multiply by 3.14 if you would like to get some approximation. Last, the cone. The cone formula is very close to base times height. It is V equals 1/3 of the base times the height. So 1/3 pi r squared, and then times the height. So V equals, let's put in some radius and height. The height is from the base up to the peak here. Let's say the radius equals 2 inches and the height equals 10 inches. So very similar to what we had with the cylinder, but it's just going to be 1/3 of that. So 1/3 of pi times 2 squared times the height of 10, and v equals 1/3 times 40 times pi, or that is 40 over 3 pi, 40 over 3 pi, and our label, cubic inches. So those are some examples for the rectangular prism, or known as a box, a cylinder, a sphere, and a cone.